All right. Rectangular coordinate system. Each point has a unique set of coordinates, x, y. If I tell you to draw a point at 2, 3, you go to 2, 3, you draw a point, there you go, okay? I'm gonna take you back to a second to one of the points that we just plotted in the last video. -1 pi halves. Another way that I could write that point is this is 270 degrees, so I could say 1 comma 270 degrees. Or in radians, I could say 1 comma 3 pi halves. Or instead of -1 pi halves, I could say -1 90 degrees. In the polar coordinate system, there are actually infinitely many ordered pairs that I could write for that one particular point. Unlike in the rectangular coordinate system, there is only one point, okay? So, polar coordinate system, each point can be represented by infinitely many sets, okay, of coordinates r, theta. Again, this is the distance from the origin, and then this is the angle from the horizontal x-axis, okay, if we call it that. It's not actually the x-axis anymore, it's the polar axis. So, how can you find various other points? One is you can add or subtract multiples of 360 or 2 pi if it's in radians. Or if you go backwards, then it's going to differ by 180 degrees, such as I did on that problem. Okay, we took, this was at 90 degrees, but then I changed the sign of r, so then I had to change this by 180. 90 plus 180 is 270. Okay. And then same, if it's in radians, it's going to be just plus or minus pi. So, find 3 additional pairs of polar coordinates that name the given point if theta is from -360 to 360 or from -2 pi to 2 pi, okay? So they're being a little limited. We can't just add 360 to this 3 times and be done, okay? So I'm going to take my point, 240, and the first thing I'm going to do is add 360. Well, of course, that's going to be too big. So I'm going to take 240 and I'm going to subtract 360, okay? Because I can add or subtract 360. So an equivalent point is 5, -120, all right? Now, if I subtracted another 360 from that, there's another equivalent point, but again, that's outside my window. Okay, they only want them from 360 to -360 to 360. So that means that I'm going to have a -5. Well, if I have a -5, I'm going to add or subtract 180 to this. So if I take 240 plus 180, too big again. So I have to take 240 minus 180, and I get 60. Now, if I minus 180 from 60, that's going to put me right here. So I have to minus 180 from 120, and I'd have -5, -300. And something that you can do, if you're not super familiar with all of these numbers, the 240 degrees, -120, 60, and -300, is you can draw yourself a picture, okay? You can take a plain old coordinate plane, or we can take a polar coordinate, and just get the idea, and again, I'll just use this one. So 240 degrees is going to be right here, okay? So -120, right here. 60, -5. Now, if I go out to 60, it's on this side, and -5 would again put me here. And then -300, I'd go around to here, and again, -5, so it's going to put me right back out on this line here. So you can double check visually to make sure that those all fit, okay? So now 2 pi 6. So pi 6 is right here. Now, because it's in radians, we're going to put everything in, we're going to keep everything in radians. If you're not good with fractions, I'm going to ignore the pi, and I'm going to take 1/6 plus 2. So this is the same as 13 pi sixths. Well, this is going to be, we'll call it too big because it's more than 2. Okay, so I'm going to take 1/6 minus 2. And I get a -11/6. Okay, so I'd have 2 -11/6. So now I need to find my other two that both have a -2 here and here. Okay, so I'm going to start with this pi sixth. And again, I'm just going to use 1/6. And I'm going to subtract 1 pi. And so I get a -5 pi sixth. And then I'm going to take this one. Actually, I'm going to take 1/6 plus 1. And I'm going to get 7 pi sixth. And then I'm going to double check that. So if I'm on my coordinate plane, 2 pi sixth would be here. Okay. -11 pi sixth, I'd start here and I'd go around 11 pi sixth, which is going to put me at that same place. -5 pi sixth would put me here, but then it's a -2, so that's going to graph correctly. And then 7 pi sixth, I'd go all the way around to here, and then again a -2, and I'd be in the same place. So all 4 of those check out.